morning, everyone. So today's topic is regression modeling. The objectives are that we have to understand the basic concept of regression modeling and where we are going to apply this regression modeling technique to find what kind of insights from the given data. So as we know that there are two different classes for task, like for example we have classification task where we are given a set of categories or classes and we have to find out for the incoming data pattern that to which class class this data pattern is going to belong to. Another class of problem is where we have to regress. We have to regress and we have to find out that what will be the future pattern or what will be the value of some future prediction for a given input. So in case of classification, we already have a list of classes or categories, and we have to simply decide that the given input belongs to which category. While in regression, what we do that we have to predict for the given input what output value this input is going to have. So in the regression technique, what we are going to do that we are trying to predict the future values or the future patterns, while in classification we have already been given certain categories and we have to associate those class labels to the given input, or we have to decide in a way that which class this particular input belongs to. So when we talk about the regression modeling, we see that regression modeling is quite useful in the machine learning domain, and there are different different types of concepts involved in regression modeling. So first of all, what we need to understand is that the regression modeling holds two different types of goals. The first goal is that is there a relationship between the two variables. So suppose, for example, if I'm going to give I'm having two different variables, so two variables, and I need to find out whether these two variables are related or not, or if they are related, what kind of relationship they are having. Then this we can determine with the help of the regression modeling. The another aspect here is to predict the future value of a variable which is dependent on another variable. So for example, if I already know that two variables, they are dependent on each other, not on each other, one variable is dependent on the other variable, and now I want to predict that, for example, if one variable is having a certain value, what will be the value of the other variable, that we can determine with the help of regression modeling. So we can also predict the future values of one variable from the other variable. Right? Now, when we talk about the variables, there are two different types of variables involved in regression modeling. One is called as the dependent variable, and the other one is called as a independent variable. Right? What is the difference between these two, and what is the purpose of these variables? We are going to explain or see to that. So when we talk about the dependent variable is the one variable which is dependent on the other variable. So for example, if I know that there is a relationship between two variables, now if one variable is dependent on the other variable, and the value of this variable is going to be changed with respect to the changes in the other variable, we say that this variable is a dependent variable. And most of the time we denote this variable as x, right? Or sometimes we also denote it, many a times it is being denoted as y variable. Okay, so in we can have different notations here, but most of the time if we go through the textbooks and all, we say that the dependent variable is being denoted by y and the independent variable is mostly denoted by x, right? So x is the variable which is used to determine the value of the dependent variable. So in that way, x becomes the independent variable and y becomes the dependent variable. So now the dependent and independent variable, they are related in a linear or non-linear fashion. So as we already have said that the variables could have different types of relationship. Now if they are related at all, they could be related in a linear way or they could be related in a non-linear way, right? The most common form of regression modeling is called as the linear regression, where we assume that both of the variables, the dependent and the independent one, they are related by a linear relationship. Now, the target variable has a set of continuous values, and what we have to do, that we have to fit some linear equation over the given data. So we have been given the observations where we have the value of the dependent variable, which is y, and corresponding independent variable values. So now we are having values for x's and y's, and we have to find out a trend or a linear line that is fitting over that data. So this is the purpose of linear regression modeling. And once we are able to find out that that line which passes through the data or that actually fits over the data, then with the help of that line or with that model, we can predict the future outcomes or the future values of the dependent variable from the values of the independent variable. So now, for example, the different types of linear regression models that we are going to discuss, most of the most common ones are the linear regression, the logistic regression, polynomial regression, ridge regression, and lasso regression. And in this lecture we are only going to discuss about the linear regression. So as I already have explained that in linear regression we have been given two variables which are related, and one variable is dependent on the other variable. So we say that y is dependent on x, and in that way x becomes the independent variable and y becomes the dependent variable. And both of these variables, they are following a linear relationship. Okay, so in a sense that we can say that when x is growing, y is growing linearly with respect to the x values. Now, as we know that we have been given the values of the x and the y, and now we need to find out a regression model which is nothing but the best fit line which is fitting over the data, and with the help of this best fit line I would be able to forecast the values of future y pattern. So now how to find out this best fit line? So first of all, since this is a linear regression model, we need to first think about that how to mathematically represent this model. So as we already remember from the mathematics classes that a linear equation is like, for example, y is equal to mx plus c, right? And in this linear equation, we are having this variable as our independent variable. This is our dependent variable. Right? And apart from these two variables, we are also having two fixed quantities. One is called as M and the other one is called as C. So technically we call them as the coefficients of this linear equation, and this M coefficient denotes the slope of the linear line or straight line, and C denotes the intercept of the line, right? In linear regression modeling, we use the same kind of equation, but it is written in a different way. So what you are going to see, usually you will be having an equation for linear regression model as y equals beta 1 x plus beta naught, right? Now again, x and y, these are independent and dependent variables, and these beta 1 and beta naught, they are nothing but the coefficients. Now what these coefficients represent, so as I already have explained that this is nothing but a reformulation or a rewrite, rewriting the same equation in a different way. So we can sense that beta naught represent the intercept and beta 1 represent the slope of the line, of the straight line, right? Now another thing that we need to focus here is that, for example, this data is given to us and these are the points. So some x values are given to us, and from x values, how the y values are changing with respect to the x, that data is being plotted here, and you can see the red line is the straight line that is fitting over the data. So this is kind of a regression model which we have identified for the given data, and by using this line equation or this mathematical model, what we can do that, for example, in future, if I see one value of x here, right, I can find out that what will be the value of y for this particular input. So this is the thing the regression model does. So the regression model does what? That it actually predicts the future outcomes of the other variable with the help of the given variable. Okay, so now when we talk about the linear regression, we have to understand it in a deeper way, and as we go deeper, we see that when we are talking about the explanation of one variable in terms of the other variable, there are certain factors that we need to understand. So for example, here I have taken up one dependent variable which is called as sales, and for example, I want to predict the value of this sales with the help of some independent variable. So for example, my linear regression equation could be like, for example, I want to decide the value of sales based on the temperature of a particular area or city, right? It could be like, for example, I want to determine the sales value from the rainfall that particular region or city or that particular place is receiving over some time. Or it could be the factor that are there holidays. So how holidays are being related to the sales, that can be represented as a linear regression model, right? Now when I already have selected one variable which is my independent variable, okay, I have explained that part. Okay, so to the model I already have said that sales can be explained with the help of holidays. So if I have been given holidays data, I can explain the variation in the sales. Similar ways, if I already have, with me the rainfall data, again, this is the explained parameter or factor here, because I already have found out or thought that rainfall in some way is going to impact the value of sale or the variation in sales. Similar ways, temperature, I could think that temperature is also an important factor that can impact the sales value, right? So all these factors which I can think about of particular, dependent variable, those comes in the explained factors, right? Now, apart from these, could there be, no other variable or no other factor that can impact the sales? There could be, right? So sometimes what happens that when we are formulating the problem from the scratch and we are deciding on that what will be the independent variables from which I'm going to find out the value of the dependent variable, it depends on my own exposure and my experience, and based on that I am picking up those variables to form the model. Now I need to understand that there could be certain unexplained factors that are also going to impact the sales figures, right? So the variation in the sales can not only be totally dependent on these variables or their combination, right? Apart from these, even though if I could consider these three variables together, again there could be a fourth variable or fourth factor that is always impacting the value of sales, right? And this I am taking up as an unexplained part. So while we are creating the models, we have to understand that what are the explained factors and what part of the model which the model have not seen is unexplained. Okay, so we have to consider both of the factors, the unexplained ones and the explained ones, while we are creating the models, because the things which we have not seen or which we have not considered while forming the model or while forming the model equation, okay, that are going to somehow impact the overall accuracy of the built-up model. Now, another aspect in regression modeling is that we have to understand the difference between the population and the sample, right? So mostly you see that there is a term which is called as population. What do we mean by population? So population actually represent the universe of discourse for a particular domain from where we are collecting the data, and it actually incorporates or considers all of the values, the past values, the present values and the future values of that particular domain. So if I'm talking about a population, that means that I'm talking about all the possible data values that can belong to that particular domain, right? So for example, if I talk about temperature, okay, I need to see that how much minimum and how much maximum temperature could there be in future also, right? So if I can get all of the data, then of course my prediction or my regression is going to be more robust and is going to give me more accurate answer, or I can say in other terms that it is going to fit the data more accurately, right? But in practical situation, it is not possible to collect all of the data belonging to a specific domain, right? So we are only having a fragment of data, and we are working on that, and we are creating the model from that data. So in a way, we are drawing a sample from the population, and this sample or the sample data is nothing but some fragment of the data that we have drawn from the population and which we are going to use to build up our model, right? So with this, inception in mind, we now try to understand that what we mean when we are saying that this is the population regression equation, right? So if we talk about the population regression equation, it is nothing but the equation which represents the data, all of the data of that particular, problem domain. So this equation is normally represented like this. Here, this yi, this is my dependent variable. This xi is the independent variable, and we are having the coefficients b0 and b1, right? These two are the coefficients, and these coefficients are the same that we already have discussed. That, for example, this b0 shows the intercept, and this b1 is related to the slope of the linear model that we are going to fit over the data, right? Now there is another term which we have included here, which represents the error. So this error term is nothing but the unexplained factors that we have not still considered, or we have not still found out while building up the model, right? So all the other factors apart from temperature, which I have not considered, which are going to impact the sales in some way, those are right now under the unexplained factors, and I have to consider them to be realistic, and this is represented by the error term. Okay. Now, the next thing we need to know is what is the sample regression equation. So when we talk about the sample regression equation, we need to be clear on that we are not having right now the whole of the data to create the model. Rather, we have considered only a fragment of this population data, and that fragment which we have drawn is nothing but a small sample from that population. And since we are estimating the population variance with the help of this sample data only, or so I mean that way, now the variable representation and the coefficient representation is going to be changed slightly. So we most of the time see equation where we are using hats over the variables. So for example, now we are having yi hat, and this yi hat is nothing but the estimated value, or estimate for my dependent variable, right? Similar ways, now this xi is my input independent variable, and I am estimating the value of yi from this small fragment. Similar ways, the coefficients are going to be changed in the sample regression equation, and the intercept is now represented as beta naught hat, and slope is going to be represented as beta 1 hat, right? Again, there is an error term which incorporates the unexplained factors for predicting the future values from the input. Okay. Now this is a sample data we can use to create a linear model here. To sum up for today, what we have learned here is that, for example, if we have been given certain data, for example, we have given data like this, okay, the objective is to fit a line here on this data. And for example, if I keep markers here, this is 1 2 3 4 6 7 10, and this is, for example, 2 4 6 8 10 12 14, etc., right, and so on, right? So this way we have seen that this is our independent variable and this is our dependent variable. Now this data we have already plotted, the problem is that we have to find out the best fit model or the best fit line. This best fit line is nothing but the best representation of the model that is fitting over the data as tightly as possible. Means capturing more number of observations on it. Right now, before going into how to find the best fit line, I will tell you that we have to fit a linear line over this data. Now, for example, my line is going through like this. Okay, suppose this is the line I'm using, and as you can see here now that the line equation which I have is y hat is equal to this will be beta naught plus beta 1 hat x, right? And here you can see that this beta 1 or the slope, how the slope is going to change up here. So you can see that I cannot simply put one single line, rather I can change the slope of this line also. So I can place a same another line here having a different slope. I can also create another line with a different slope. I can have another line passing through the points with a different slope, and similar ways I can draw infinite number of lines with different types of slope. I also can draw a line here like this, which is having a negative slope. So infinite number of such lines exist in this two-dimensional space. So in a way, this coefficient beta 1, that this actually controls the slope of the line, right? Now the next coefficient is beta naught, which is the intercept. Okay, so intercept is what, and what it is doing here. So when we talk about beta naught or the intercept, it actually tells us that on y-axis where this line is going to cross. So for example, right now the line which I am talking here is passing on y-axis from marker 4. So I can say that value of intercept is 4 here, right? And for example, if I put another line from like here, okay, or like this, I can say that intercept here is 11. So intercept tells us that on y-axis where this line is passing or crossing or intercepting, right? While this beta 1, it actually controls the slope. The slope could be positive, it could be negative, and with that information, we are able to find out that we are able to draw multiple lines in this two-dimensional space. Now, apart from these lines, which one is best fitting or which one is best representing this given data, so that I would be able to predict the future values as accurate as it is possible? For that, what I need to do, that I need to find out or estimate the value of these coefficients. And how we are going to do that? So to estimate the value of the slope and intercept, what we need to do, how we are going to find it out? So again, this is going to be found out from the given data itself. All right. So value of coefficient is actually being estimated from the given data itself, and then we are going to have a linear regression model when we are putting up these coefficient values here, and they actually tells us that how one variable is changing with respect to the other. And for example, if you get value of beta naught, for example, as 4, and beta 1 as, for example, 3x, so this becomes your regression model. And when you put the value of x in here, you will get the value of y from this equation. And this is the fundamentals about how the linear regression works. Thank you for today. Thank you.